We're here with Bill Wilson, president of Specified Systems, Inc., the Pittsburgh-based distributor and erector of commercial windows, aluminum storefronts and doors, and aluminum curtain wall systems. Bill, there seems to be some confusion about Low-E glass. What is Low-E glass?
Well, first, there's a lot of confusion about Low-E glass, and the amount of confusion about Low-E glass in the architectural building industry is unmeasurable. I mean, there is a lot. What Low-E glass, to give you a little historical background first. Low-E glass means low emissivity. That means if you took a piece of just plain clear glass versus a piece of low emissivity coated glass, the design of low emissivity glass is to mirror heat. Okay, whereas more so than what a regular piece of glass would, because a single piece of glass really isn't that thermally efficient. Low-E glass was developed at Massachusetts Institute of Technology on a DOE Mellon Foundation funded grant. That technology was purchased by a company called Southwall Technologies from Palo Alto, California, and they developed a suspended film with an almost clear 5 metal coatings film on it. It was an acrylic film with 5 metal coatings on it, and they called it Heat Mirror 88. And they went out and marketed this product to be suspended in insulating glass units, all right, and called it Heat Mirror, all right. Shortly, and this occurred in the mid to late 70s. Shortly thereafter, Ford Glass Division, the glass division of Ford Motor Company, came out with a product that had the similar metal coating, pyrolytically coated, hard coated onto a piece of glass, and it was called Ford Sunglass, and then it became known as Sunglass Heat Reflective. And that pretty much simplified what it was supposed to do. It was to reflect heat. Subsequently, AFG came out with a product called Comfort E, and then Comfort E2. PPG came out with Sungate 500, then Sungate 100, or maybe in reverse order. But everybody in the glass industry came out with a hard coat, heat reflective glass product. Now, the idea behind this was that the sun gives off, from our perspective in the glazing industry, it gives off visible light, it gives off infrared, which is heat, and it gives off ultraviolet rays. Ultraviolet being what fades your furniture and your carpet and so on, and the infrared, of course, being your heat. The heat reflective glazings offered a secondary benefit in that they also filtered UV. Okay, so by putting a heat reflective glass in your home, as an example, you would cut the amount of ultraviolet fade on your furniture, your carpet, your floors, and so forth. Great idea, because what would happen was it would allow the heat to come into the room. That heat would retain, the wavelength pattern of the heat would change. It would combine with your heat-driven source in your home, whether it was gas, forced air, radiant heat, whatever it was. And as it went to your windows, because heat's always drawn toward cold, as it went to your windows, it would mirror it back in. Okay, so that essentially is what Low-E glass is. Now, as that industry evolved, if you've ever been to the airport and stood in front of one of these great big walls of glass when the sun was shining into them, you would notice that the heat could be almost unbearable. And this is how we say to people in the glass industry, how do you know that it has low solar heat gain glass versus conventional Low-E glass? Well, you can tell by standing behind it. And most people recognize, they go up to it, it's so stifling hot that they can't even stand in front of it anymore. And as they move back, it gets cooler. Okay? Well, what happened with Low-E glass, it was a tremendous idea, unless you put it in these big glass walls or these big corridors of glass. Because what it was doing was allowing this enormous amount of solar gain and then it was mirroring it back in, creating kind of an incubator effect. Your major glass producers then decided, well, they need to come up with something a little bit different, and the technology was developed and introduced in our market by PPG to come up with what they called a low solar heat gain coefficient low E glass, which was a soft coated glass, non-pyrolytic, a sputter coated. So it was actually a coating that went on the glass that would allow it to be still as thermally efficient, but would not allow as much gain into the room. Okay, so ultimately, then the market started to swing over to this whole new technology that came out there. And you had our primary sources, Guardian and PPG, come out with these with what are now their basic products. Guardian's is SN68, PPG's is Solar Band 60, and they're kind of commodity class products now. And then that technology is continuing to develop with other different classifications of the soft coat, high performance, low solar heat gain coefficient glasses. I can't even keep track of them all. I get them wrong all the time. But Guardian has like an SN54. PPG has a 70XL, I think, an R100. I mean, there's all this a whole array of products that are designed to fit particular applications. But the element of there is still the hard coat low E, and there is the low solar heat gain coefficient low E, and that's where all of the confusion is.
Okay, so one type of low E glass allows for solar heat gain and it holds it in the building, and the other doesn't. How does the specifier choose what they should use?
It's pretty simple. It gets to be very, very simple. If you're going to design a building that has a bunch of narrow punched windows in it and has a higher percentage of other surface wall than glass, then the likelihood is that you're probably going to want to allow a little bit of solar heat gain and hold that solar heat gain in the building. If you're going to have a wall of glass, where glass is a major component on the building envelope, such as you have a lot of curtain wall, or in a school where you have big entrances of glass because you want to be able to see in, you want people to feel welcome in that school. You're going to, in those cases, be using the low solar heat gain coefficient glazing.
So from a practical perspective, you see the hard coat low E being used in residential applications only?
Well, that's where I would use it. Yeah, I would keep it pretty much to residential applications, because what you're talking about there is you're talking about your average home has 11 windows in it. All right, these are people who want to conserve energy but still want to have the availability of daylight. You get a higher performing product. It allows some solar heat gain. It helps in the winter time by allowing heat into the building and helps hold it in there. The difference is that if you use the hard coat low E product in a commercial scenario where you have a lot of glass, you really have more of an incubator effect than you do a thermal performance effect. So the HVAC conditions, the heating, ventilation, air conditioning considerations on a commercial building are closely calculated and closely regulated. So what you want to do with your glazing package is try to keep the inside of the building as close to the generated temperature as possible. Therefore, in those cases, your architect, specifier, building owner would want to investigate using the low solar heat gain coefficient glazings. And it's also very easy to interpret in specs. The bar for low solar heat gain, and you'll see that on the charts, it's SHGC, and when you look at that, it'll be a 0.4 or under is what your commercial specifier would want to be looking for.
Is there a brand of low solar heat gain glass that you would recommend?
Well, obviously, as I mentioned earlier, since we're glazing connection partners with Guardian, and since we're closely connected to the glass specification unit at PPG's headquarters, we would prefer to see every specification say PPG, Solar Band, or Guardian SN products. I mean, those are, and they're the domestically produced products. Those are the ones that we prefer. Obviously, neither one of those companies is the largest glass producer in the world, but they are your domestic producers, and we like to support them. We get a tremendous amount of technical support from both of those companies. They're both great companies. They both have, for us, they both have production facilities and offices in Western Pennsylvania. So we are always leaning toward Guardian and PPG.
Well, thank you for the clarification.
Thank you.